all we're doing is A and B. Just doing A and B and that's it. Right? And then we're going to do the chi-square. Right? So look back quick, do that fast enough, so we can spend most of our time on chi-square.
Sir,
Yeah.
naman sir, naman.
Okay, so you do this in the fast and then message about it, right? Right, so what we using here? Which option this was? Yeah, Chidan, I have a question there. We're just doing one, right? And I wasn't time, it takes too long to spend. So let's just do this one to refresh ourselves about confidence intervals, and then we move on to hypothesis testing. Right, so how we, Amber, so how we doing this one? They didn't tell us a distribution to use here. So what we can do? Right, they didn't tell us what distribution that we can use, so what we gonna do here? They gave us a mean and they gave us a standard deviation. Using formula, no, but before you use the formula, you have to state something. Queen blank on YouTube. Assume it's normal, no, you have to use such a central limit theorem first. Alright? It's blank on YouTube. Hold on, huh? Don't know why, probably stick. How about now? See it now, Taylor? See it now? See the screen now? See the screen now? Okay. Hopefully it'll show up on YouTube just now. Alright, anyway, let's work out this fast, right? So, right, so what we can see now is by central limit theorem, x bar follows a normal 0.93, standard deviation 0.1 squared, right? You have to state that first before you do anything. Okay, now you can use the formula number, right? X bar plus and minus your sigma and root n. What's the value you all got for 99%? Remember what to do? Come up here. This is 99%. So here is 0.5. Here is 0.5. So the value you have to read off is 0.995, which corresponded to what? Which corresponded to 2. Which corresponded to 2.576. 2.576. Oh wait, I'm now seeing a problem here. Anybody recognize a problem here? Seeing a little problem here, right? Yeah, we could use this value 0.93. But I've seen a little problem here. I don't know if you all read it closely. Watch what it says. A random sample of 55 sweets. They gave you the mean mass of the 55 sweets. So that mean mass will still be the mean of the distribution of the X bar. Watch what they give you. They give you a standard deviation of the sample. So what they really give you is S. That is not sigma. So to get sigma hat or sigma hat squared, remember the formula that we had to use? What's the formula you have to use if you have S? If you have sample, well, in this case, we have sample variance, right? Because S squared is 0.1 squared. How are we getting the estimated variance for the distribution? How we getting that? Anybody? Right, very good. N over n minus one s squared. So I really like the question. Even initially I read it quickly and I missed that. Right? But it didn't give you anything for the population. It gave you everything for the sample. So read it again. They give it everything for the sample. I don't remember why I wanted to do this one. Because I wanted to highlight that. Right? A random sample of 55 sweets, right, was found to have a mean mass. So that mean, we know that mean could be used as the mean for X bar. And then they give you standard deviation for the sample. Okay? So that's S squared. So S is 0.1, so S squared is 0.1. So that's 55 over 54 by 0.1 squared. How much is sigma hat squared? How much y'all got for sigma hat squared then? Anybody? Zero point zero one. The whole thing, right? When you multiply it out. So sigma hat squared is 0.01. Everybody get that right? Two decimal places. What's the exact value? Don't round up too much. Darian, what y'all doing? Just to plug in that value there. You're outside the yard, feeding the dog or something. All right, yeah, carry it on with the question than that. 0.0101 or something. 02. Yeah, finally. So we'll leave it like that. So now we know what sigma hat squared is, right? So now we can see X bar, which is 0.93 plus and minus. You'll say you got 2.576 for 99%, right? Remember you're reading off 0.995, right? Sigma is the square root of 0.01 all over the square root of 50. Any questions there, Olia? Anybody, any questions? Kiran. Babisha, you follow what going on? Now we'll call that some way you get this. Well, what you get paid two limits. So why is the square root of 50? No, that's 55. That's 55, Daria. Pay attention now. What you all that? Right? Damian got. Bradley, you working on anything? Bradley, your mother was just here today.
One sec, sir, one sec.
Huh? Pay attention, Bradley. Anybody else get up?
So I got 0.965 or 0.895. I don't know.
Go. In the same value? Take it back. Anybody else get it? Keelan got it. Anybody else get it? Bradley, Amber, Darian, Jaden, Ravisha. Anybody else get it? Alianzana.
Oh, so I missed it by like 0.3, but you know.
You got Bradley answer. Hold on. Let me get my calculator. I am getting 0.895.
Oh wait, so I realized I going wrong there. I realized I going wrong there. So I didn't use the sigma hat value for the answer. So my answer was kind of off there.
If I get some different, I get 0.895.
Yep, so that's without the sigma hat value.
That is with square root of 0.01.
No, well, so that's what I get at first, right? But when you use the sigma hat value, then you get 0.863 and 0.997.
Right, but and sigma squared was 0.01, right? So
Yeah.
So sigma will be the square root of 0.01.
Right, so the answer is 0.895 and 0.965.
Yeah.
Okay.
Yeah. Right? Damian, Kaylin, what you all use? Remember, it's the square root of 0.01, right? What you all use? Okay, well, that's why I use and I get those values, right? Okay, well, I'm not sure. Check it back again. I plug in the same thing. Check and see where your brackets and things. Right, just make a note quick. All right. So today's class was important. We reached the last part now. We remember the objective of us was kind of to deal with the mean and see how the mean behaves something in different scenarios, right? So initially, we try to get point estimates of the mean. So I'll give you values in a sample. I'll give you values from a sample, you put it together, you add it up, divide by, and then you find the mean, right? Then we looked at finding a range. We looked at finding a range where the mean is, right? And now the confidence interval. So you want it to be 95% confident. You take a mean value and you plus and minus the statistical value from the sigma and root n. That's the confidence interval. If the sample size is too small, it's a t-distribution and so on, right? But now we go into our next technique, and that technique is what we call, right? This is the only thing that's a little bit challenging in this unit, right? Hypothesis testing. So what I'm going to do is I'm going to do chi-squared. Chi-squared is the one that that's a little bit easier and it's allow me to see the concepts of what we're doing, right? So we're going to take a look at hypothesis testing using a technique or a new distribution called chi-squared. All right. So let me just, before I jump into this, let me just show you how to read chi-squared, right? So chi-squared has a special property. It looks like this. Chi-squared, you need two things in a chi-squared. You need to know the significance level and something called the degrees of freedom. So chi-squared, let's say the significance level is 5%. That's 0.05. Degrees of freedom is V. Right? Let's say the degrees of freedom is 4. I want to show you how to get the value, right? Do me a favor. Go to your chi-squared table. Right? Go to the table that you would have gotten for chi-squared, right? And the chi-squared looks like this, a distribution shape something, right? The distribution shape, something like the normal, right? But you will see it's skewed a little bit, right? It's skewed a little bit on the left side, right? So we need to be able to read it. Do me a favor, go to the table and tell me on top of your table, which side of your chi-squared is shaded, to the left or to the right? Check and see. Which part of your chi-squared is shaded, to the left or to the right? Left. To the left is shaded, okay. Only same people answering over and over. I need to know that you're all there, right? Darian, Ravisha especially. Ravisha, are you there? Okay, pay attention, huh? This had to go in the SB that due on Friday. Right. So you have your thing looking like this, right? Nice. So what you have to do is go to a table, right? You will see a table looking like this. On the left-hand side here, you should see degrees of freedom. So you're coming down to 4, right? And then you want to read off the 5% level. So to read off the 5% level, right? What you already reading off is 0.95. So you come to the top of your table, look for 0.95 and see where it coincides. That's your value. Everybody message what you get. Message where two of them coincide. If you don't respond, I'm moving you out of the group, out of the class. Message what you get, please. All right, good job, Kaylin. Darren, give me an issue. You're reading up 0.95, huh? 4 degrees of freedom. Oh Lord, what is that? Check over your children. So you know when is iron due for physics? For Friday. Wait. All of you know. No. All in listen, Amber, you're not listening. You're reading up 0.95 on top. No, you're not using the T distribution, you're using chi-squared. Go to the same handout I sent you all, and you will see something shaped like this. With an X on top, like chi-squared. Right? So you're reading off 0.95. So look at the top here, you'll see 0.954. Right? Correct, Cheated. Correct with Bishop. I only have 3 correct so far. Anybody else? Waiting on all. Darian. Damian, correct. Bradley. Correct now, Amber. Hey, boy, you're good, Gary, man, boy. Bradley, what you doing, boy?
Oh. 9 point. Nah.
Darian, that wrong, boy. And now tell it to watch 0.95. 4 degrees of freedom. Correct, Christopher. Bradley, what you doing? Oh gosh, boy. Good job, Darian. Thank you. Just waiting on Bradley now. All they can keep back at class. Bradley, you must just skip mother time to push you and pay attention. Push you one time. Oh, Bradley. Right? Okay, good. Bradley, you're going to the chi-square table, the thing that looks like this, and it's shaped something like this. It just skewed a little more to the left. Right? And look 4 degrees of freedom and this. So when you all see a significance level, right, regardless of what it is, you are not reading off this value here. You are reading off 1 minus that value. But the table you all have most likely looks like this. 1 or 2 schools have this side shaded. If this side of the table shaded, then you're reading off this. Right? But we don't have to worry about that because the ones that we have look like this. Left-hand side shaded, and we're reading off this value here, 0.95. 0.95, 4 degrees of freedom. Come down, see where they intersect, and that's the value. And you all got 9.488 or something like that. That was good. Nice. So once you see chi-squared, you need 2 things. Significance level, degrees of freedom. So this is the distribution that we're using today. Right. So how do we do a hypothesis test? The first thing in a hypothesis test is that we need to get hypotheses. So we need to get something to test against. Right? So we need to get something to test against. And then if this is found to be false, yeah. Right? If this is found to be false or this is not true, then we go with this. We call H0 our null hypothesis, and this is the alternate. Normally it represents the opposite. Right? This is the alternate, right? So the one that we are doing in chi-squared, we are doing something called test for independence. So you're going to see me give you a set of values. Let's say X and Y. 1, 5, 7, 3, 4, 2. That's making up something, right? I'm going to give you a set of values. And then what we're going to do with those values, we're going to check and see if one is independent of the next, right? So we're going to test for independence. So our chi-square test is called a test for independence. So all I'm doing is this, right? For example, paying attention in class and getting a good grade, those might be dependent on each other, right? So if I give you variables like that, then you should expect the test to show dependency, right? But something that independent might be eating popcorn and getting a grade 1. Those two things might be independent of each other. We are testing for that. Okay? Everybody okay with that? We are testing for those two things. That's okay. So our H naught, we'll do some specific ones just now, but our H naught is always say no effect or here effect, or no effect basically means they are independent of each other. And our H1 does normally say that they affect each other. So they are dependent. So these are normally the statements that we go with. Right? No effect or independent. Independent means one don't affect the next. And dependent means one affects the next, right? Like paying attention to class, Bradley, paying attention in class.
Yeah, sir.
Right? Okay, so that's normally the way we set these hypotheses up. Now, what do we use to test it? Well, what we develop based on the information given, we develop something called a critical region. Right? We develop something called a critical region. What that critical region tells us is that if we end up in that region, things bad. We have to reject H naught. So see like here, that is normally our critical region. So if we end up doing our calculations and we end up into that region, we're going to reject. So critical region, once we end up inside here, inside implies rejection. Means we're going to reject this fella here and go with this next fella here. Yeah, Sana? So we're going to reject here. If when we do our calculations, we end up inside here. So how do we get that boundary? How do we get the critical region and the non-critical region? To get that boundary, what we do is we go to the tables and we read off chi-squared value at the given degrees of freedom and significance level, right? Once we go to the tables and get that value now is the boundary. Once you jump into that critical region, you're going. You're rejecting H naught and you're accepting this. That's okay? So the critical region is set up by knowing this value. Once you end up greater than this, that is your critical region. So your critical region is greater than your chi-squared alpha value. This value is what we call the table value. That'll come from there, right? That's this value here. So if we have a table value, we should also have a next value that allows us to compare. That's called our calculated value, right? So number 1, well, that will be number 2. After we start to work this out, we get the critical region. CR means critical region. We get our critical region. Once we get the critical region, right, the next thing that we could do, really and truly, I kind of jump a step there, right? Is get this V after. So let's put this as number 3. Number 2 is to get the chi-squared calculated value. You normally do this second. right? Because after you do the calculated value, that will help you figure out V. V is called the degrees of freedom. I'll show you how to get that in an example lesson now, right? So technically, you need this first. So how does get a calculated value? Well, you will observe, you will recognize that I'm giving you who's the observed values, right? I'm going to give you some values. So what you just do is we're going to have to work out expected values. And to get these values, I'm going to show you how to get them. We get them from a table, right? That table is a contingency table, and I'll show you how to use it, right? So we're going to take the observed minus those expected that we work out, square it, and then divide it by the expected. And then we're going to sum all of that. Okay? So I'm going to show you all this, don't let us confuse it. There's just the formula you're using, right? So I'm going to show you how to do all of this. So you have the observed. I've given you that. You have to work out this. When you work it out, you follow this formula and add it up. And then when you get this value now, after you do that, you're going to get the critical region, and 4, we're going to compare chi-squared calculated value and the chi-squared value from the table. Okay? You're going to compare them. If this fella bigger than this fella, we're going to reject. Because if this fella bigger than this fella inside here, right? So we're going to reject H0, and we're going to accept H1. So we're going to reject independence and accept dependence. But if chi-squared calculated is less than, and it falls in here, then we do not reject. Then we do not reject H0. So basically, what we do is we accept H0. All right? So this is what we're doing. Set up your hypotheses. Get your chi-squared calculated value. I am going to show you how to do this now. Then get your critical region using the degrees of freedom that you have here, right? And set up a critical region, and then compare these two fellas. If this bigger than this, reject. This smaller than this, accept. That's okay? We can make a little summary on the steps. Please switch them around, right? Put this as number 2 and this as number 3. This is the number 3 and number 4 is compared. And your last step is to write your final statement. All right, so we are going to do an example now. Copy it down first. Is that okay with that? Anybody confused? Say yes or no, please. Everybody online. If you're confused, say yes. If you're not confused, say no. I ain't say good, Damian, or the boss, I mean, don't listen. Yes or no? Or the boss, I mean, right? The rest of people, Jaden, Darian, oh gosh, boy, Darian, boy. Every Monday night, boy. And Wednesday and Friday. It's whole week, boy. Whole week, boy. Well, I asked you to say you understand. Now you, Jaden, talking about Darian and Bradley. Oh,
Yes, I understand.
Who Bradley message me now? All right.
Yes.
So we're gonna put this together, right? And then killing deal not paying attention at all. All right. So we're gonna copy them if you need it. Right? I don't think this in the summary as and all they want. These are your 4. Your 5th step is to write your answer. So the problem with this is that we need to find a way to put them into a table, right? Let me take it off. I was taking off the first part. Them values too small, right bigger. Too bad. All right, I'm ready. Better? Right, everybody ready? I'm gonna do this full question, right? Everybody ready? Ready? Let's go, right? So nice. So here's what we need. We have a home and away here, and how the team did, right? Like pretend have enough losses here. Barca's team is really good. So Barca, right? So you want to check and see if the results that Barca obtained last year, if it dependent on if they were home or away. Okay? So there's the results when they were home, playing home, or if they were playing away. Right? For those who don't know what football, like killing and thing. So when they play a game in your stadium, that's called home. And if you don't play it in your stadium, it's called away. All right. So we're going to check and see something here. Right? We're going to check at the 5% level. We're going to check and see H0. They're not affected by each other, right? So they're independent. We're going to see if results independent of being home or away. Right? I just put in independent of location, right? And our H1 is the opposite. Results are dependent on location. Right? So those are our hypotheses, H0 and H1. Right? The next step now is for us to do the calculations. So we want to get chi-squared calculated. So remember, chi-squared calculated is the summation, and I'm going to do a little table there for you of the observed minus the expected squared all over the expected. All right. So all our observed values, I'm going to write it down. 12, 4, 5, 8, 7, 14. We're going to find our expected. So how do we get our expected values? To get our expected values, there's a nice little formula I use. You take the row total, multiply it by the column total, and divide it by the grand total. Row total, column total, grand total. So you're taking the row total, multiply it by the column total, and divide it by the grand total. Okay? So let's get those totals here. 12 plus 4, that's 16, 13, 21. Right? This grand total here is 10, 20, 30, 40, 50. Should be the same thing here. 7 and 7, 12. 12 and 12 is 24. 12 and 14 is 26. Right? Everybody okay with that? If you get lost up, right? Please don't play game, pay attention. You're sure to see this, right? Right? You're sure to see this in an exam. Sure. As I said, this is the easier one. Once you understand this, right? It will just give you the intro into the real thing that we're doing next week, right? That's the harder one on me, not the real thing. This real, right? So how do we get the expected value, right? So I'm gonna do a calculation here for you for the expected value for 12. So I'm going with the row total, which is 16, by the column total, which is 24, divided by the grand total. That will give us the value of the expected. How much is that? I have 7.68. Just check out here, correct? Yeah. So that's 7.68. Right? You're doing the same thing for 4. Row total by column total. That's the column 4 belongs to. All over grand total. Right? And I have here 8.32. Right? You do the same thing for 5. 5 is 6.24. You do the same thing for the next one, 8. That's 6.76. 7, 10.08. And last one, 10.92. Right? Once you do this properly, all this should sum to the same thing, right? Same thing. Any questions there? You're okay with that? That's the way you get here. Keelan, Darian, you okay with this? Right? Now, last step in the calculation. We're going on take 12 minus 7.68, square that value and divide by 7.68. I just doing one, right? That value is 2.43. Check it and make sure. And the next value is 0.246. The next value is 0.941. Next value is 2.243. Next value is 0.227. I just minusing, squaring, and dividing by this, right? And the last value is 0.868. And when you sum this here, that will be a calculated value. Right? That will be the sum of observed minus expected squared. Tell me what you get. I do have that. This value here is your chi-squared calculated. I don't all of this now, please. I don't have it. Hello. This is 868 area code. Catch it? 868. Healing got 6.995. Anybody else? Oh Lord, Bradley get 2.43. Bradley, you can't get 2.43. This alone is out. What's the fourth number? 2.243. Right, I'll go healing 6.956. Right, nice. So again, 6.956. That's a calculated value. It takes a little while. Hopefully in the exam we will get a lesser amount of values, right? That's step 2. Step 3 now is to get chi-squared. You want 0.05 because I told you the significance level here. The question will tell you at the level, whatever. Significance level here is 5%. Right? So that's 0.05. Now for the degrees of freedom. Here's how you just find it. Real simple. You go back to the original table and you find number of rows minus 1 by number of columns minus 1. Right? So that would be chi-squared 0.05. Number of rows is 3. Number of columns is 2. So that will be chi-squared 0.05. 2 by 1. 2 by 1 is 2. How much is that? Right? So it will tell us our rejection region. Right? Go to a table. What you all got for the rejection region? Right? Remember, you're reading off 2 degrees of freedom and you're reading off from the top of the next column 0.95. How much you got? $5.991. That's something wrong. 2 degrees of freedom. 5 point what? Oh yes, sorry. Anybody else? Killing at 5 point something. I don't have my table one. 2 degrees of freedom, yeah, 5.991. Right? Right? So basically, I'm squeezing the answer in right here. Chi-squared calculated, so this value is 5.991. Chi-squared calculated is more than chi-squared 0.05 at 2 degrees of freedom. Right? This value bigger than this value. Therefore, we reject H0 at the 5% level. Right? And we conclude that results, I can't fit it in, right? So, right, conclude H1, right? The whole thing, huh? So we conclude that results are dependent on location, right? So results are dependent on location. So after you show this, you just write conclude H1. Write out H1. My space has kind of run out. Okay? Please make sure, do not just write reject H0. Reject H0 at the 5%. Because if I change this to 1%, you will end up doing the reverse, right? Accepting. So this is important, the level is just that. Run it through. Any questions? This is your intro into hypothesis testing. This one's simple because the rejection region is the same all the time. Sometimes, and the hypotheses are the same. Sometimes it's difficult. You have to figure out the hypotheses to figure out the rejection region. Right? That's what we're going to do next week. But once you have an idea, I'll be able to continue from right there. Everybody clear that? Anybody confused? Right, so Amber, that's
Sir.
the thing with the project, right? Yeah.
Is he the last thing we have to do?
Oh, do right conclude H1. After you write, we reject H0 at the 5% level. The next thing you do is you say, we conclude that the results that Basa or wherever, you write the results are dependent on location. Right? So you write out what H1 is. You okay with that?
Sir, is he the last thing we have to do?
What's that?
Is he the last thing we have to do or no?
No, we still have more. See, like how we have more cases. We
Yeah.
have more, right? Here we had more cases in confidence interval. We have
Yeah.
more cases. We have about
Okay.
a few more cases, but I'll generalize them and make it easy.
Yes, sir.
Why you don't want to come to class no more?
No. I just asking.
I just want to know why you're asking. No, look at us.
Sir, don't worry, I'll come. Don't worry.
Remember, we're almost done. Yeah, like 2 classes again, and we're done. Right. Any questions, Olia? Everybody okay with it? And I'd like to do one. But let's see if I can find one. Sometimes the past papers don't make it to the whole thing. Hold on, let's see if we can pull up one. Oh God, my iPad no. So I will have to do this. Here what you will do. Because next week Monday is no class unless I want the class. All right. Mine's not loaded. Go to 2021. Go to 2021 and I want you to try. You do the homework because it will take it some time. In 2021, there is one on number 5. In 2021, there's one number 5. I think I shared that here in the group. Anybody can share in case it's not there? 2021 number, sorry, not number 5. Number 6. Yeah, number 6. Anybody can share it? Let me just try it back again and zoom, right? Hold on. might work. It would boy Jada boy. Right, so watch here. So a sociologist selected a random 140 leaders of a firm to investigate the effects of different leadership styles on the satisfaction of employees. Right? And they set up a table. Low, acceptable, high, and leadership style, strict and moderate. So the same thing, same 3x2. They wanted to develop the null and the alternate. You know what null is always the independent, alternate the dependent. And they gave it here. They only wanted it to work out the shaded ones. Oh wait, no. Or they wanted all. Yeah, they were all, they want all. Right? So they want it all. So you use the table and you finish off the expected values, and then you get the chi-squared test value. Okay? So you work on test value, you create a critical region. Right? You create a critical region and then you work it out. Right? So I want you to do 2021 for homework. So next day, what we'll do is we'll go straight into this. Could somebody share the paper in the group, please? 2021.
Fine, 21, sir.
Yeah, share 2021 in the group and say do number 6A for homework.
Okay.
Please do it.
Wait, the entire question, the entire 6.
Yeah, number 6A in the paper. Please do it. God is watching you. All right. So work on that, Kaylin. Kaylin, are you there? Right, you'll bring us in school tomorrow from now, right? So do it one time now. Take it 5 minutes. Do it now for me one time. Because I want to see this tomorrow. Right, everybody else, you all can log out, enjoy Carnival, be safe, and I will